Welcome to another ActivePort video series, and today I'd like to take you through the addition of our network function virtualization feature as part of our ActivePort OS software solution, which is targeted for SD-WAN. I'll just give you a quick overview of where we're currently sitting with that. For our customers that are familiar, we have been releasing ActivePort OS as a SD-WAN software solution for some time, and that software can be put onto any x86 hardware solution to provide an SD-WAN packet-based offering. Recently, what we've done is we've included now the addition of network function virtualization into the SD-WAN software. So now you can spin up virtualized environments such as VNFs for firewalls and other types of applications. Equally, they can be containers. And you can also manage that through ActivePort, which is acting as a MANO to manage the whole particular solution. In terms of firewalls, we've worked with 12 or 13 of the top firewall vendors and had their virtual images certified on ActivePort OS, and we'll take you through a little bit of a demonstration on that later. Let me go straight into a demo then, and I'll go straight into ActivePortal here. What you're seeing here is I've just logged on to a demonstration system, and I've connected onto my SD-WAN appliance. So this is a universal appliance that is acting as an SD-WAN solution. So if I can go in and configure that or set this particular box up, what you're seeing here is the configuration options of this particular box. I'm not going to go through all the options. I'm going to really focus more on network function virtualization. But in the context of what this box has available to it, this ENP4SO, which is connected, is actually a LAN interface on that box, so that's connected into my local area network. I've also just added an interface, and I did that by clicking on add and adding an interface. The name really doesn't matter. I called it BR0 to represent a bridge, although it's not really a bridge. But any interface can be created, and this becomes the host chain interface that allows you to connect the SD-WAN component to different VNFs that are running as part of the network function virtualization architecture. Then what I have is, they're the interfaces, and I have a number of WAN legs. These are WAN circuits, and in my case here, in my test environment, I've got two WAN circuits which are physically connected via Ethernet and DSL, and I have a standby 4G interface. So there's three WAN circuits. They're all bonding together to give you a single TVC for the packet-based SD-WAN solution we're offering, and we're sending down a single IP address down those three WAN legs. So here we have an open public IP address that is being terminated on an internal interface within the SD-WAN software. The WAN circuits don't really matter. This IP address will always be consistent. You can think of this as being the LAN side of the SD-WAN solution. The legs are the WAN side of the SD-WAN solution. So this pops out on the LAN side, and this is important as we get into network function virtualization. When you click on the NFV tab, it opens up the capabilities of now working with VMs or containers as part of our solution. You first have to install an agent, and I already have that installed to do this demonstration. For existing customers that already have our SD-WAN solution, the NFV tab will just appear. The agent will not be enabled. You just go through and you activate that agent, and it will download, and it becomes the basis of how we manage NFV. But to use the solution, you first need to download an image from some sort of external source. In this case, I'm using an S3 bucket. So we can come in here and download images from my AWS S3 bucket. They're stored externally, so ActivePortal doesn't store these images within our product ourselves, and that's to ensure that we don't breach any specific vendor licensing rules or legal issues. So the customer owns their images and are obviously clearly licensed to be using them, and they would have them external, and we can download those images into the universal CP. Once you've done that, and in this case I've got two images down here. I have a MikroTik CHR, which I'll demonstrate from, and a iOS image that we can install on. So what images are down there? These are ISO, so they're installable images. And to get that running, I simply click on Guest. I want to add a new VNF onto the system. The templates give you some base configuration depending on what you want to do in terms of memory, virtual CPU, etc. In our case, I want to use an installer capability. The disk is for those vendors that actually send you a QCOW file, which is a sort of semi-pre-installed. In this case, because we've got ISOs, we want to mount the ISO file and install it. I want to use a MikroTik. I'll give it a name. Originally, I'll give it MikroTik. Pretty much leave the memory, CPU as it is. Leave the interface types as that for this demo, that's fine. Now, these are the two important parts. What this pass-through interface gives you is really the LAN. This is the LAN interface of this firewall, and then the bridged interface, which is really the host chain interface, is connecting it into the SD-WAN software. So I mentioned those at the start. And when you're ready and you've got your particular profile set up, you just go deploy. So what we do here is we're going to be mounting the ISO, which we've now done. It'll start its install process, and we come into a typical MikroTik install. I want to do all install. I don't really care about the old config, and just go yes. And so now it'll actually start creating a QCOW file in this particular instance, install its software modules. It's now stored, asked to be rebooted. I can reboot it. It'll now reboot that new image. And hopefully we'll just go straight into a MikroTik front end, and we could probably log in as admin. There we go. Clearly, you'd want to change the admin password. I won't check the licensing, but we're basically into it. So if I go into interfaces, if I spell it correctly, interfaces, print, you'll see that there's two interfaces that have been connected to that. The first is the BR0 interface, which is host chained into the SD-WAN software, and Ethernet 2 in this particular case on the MikroTik is passed through to our LAN adapter. So now the customers can go in. They can also they can configure the box through this particular console. They can spin up a web interface through to it, or they can, in this case, they can spin up Winbox and configure the MikroTik. Now that's running. I can close that down. What you'll see here is that we've got that VM running. We can do all typical things that you can do with the VM. You can shut it down. We can reboot it. You can also go in and have a look at how it's been configured in terms of what's running on it, what interfaces are being configured, which we did, what disks are being configured, what the configuration is doing. In this case, we're using libvirt and KVM to spin this up on our universal CPE, and so this is the configuration for that. And I can go back and connect as a console, which I did previously. And if I connect into that, it'll take us back to where we were. Probably better off to quit and get out of that. Put it back to the login prompt and close. And that's network function virtualization. And so in that short time, we've spun up a managed firewall, put it onto the universal CPE, and through ActivePort, we can configure and manage that particular firewall. Thanks very much.